98. Which of these molecules and ions contain polar bonds, and which of these molecules and ions have a dipole moment? And then we have ICl3. So does ICl3 have polar bonds? Does it have nonpolar bonds? Does it have ionic bonds? Well, the key to answering this question is seeing what bonds are in this molecule. Now, I'm looking and I don't see any bonds, right? Generally, when we're talking about bonds, you have to see either a single bond, double bond, or a triple bond between your two elements. But I don't see any bonds here. So my suggestion to you is just take a second and draw the Lewis structure. Lewis structures are super, super, super helpful. They can unlock a lot of information, especially when you're talking about polarity, dipole moments. So that's exactly what we're going to be doing here. Now, there's tons of videos on the channel just designated to helping you draw Lewis structures. So if you do need more guidance, you could always check back on those and I'll be there every step of the way for you. This one will kind of be a quickened version. So my suggestion is you could pause the video and see if your ICl3 drawing matches mine. Now in this case, we have I in the middle, surrounded by 3 chlorines. It does not matter what orientation you put the chlorines. I'm just going to put 2 on the side and 1 on the bottom. And then each chlorine should have a single bond connected to the iodine. And then because of that, each chlorine needs to have 6 electrons. So 6 dots, 3 pairs to get the octet. And then we'll worry about iodine. Iodine has 7 valence electrons. So it used 1, 2, 3 already to make that bond. So you got 4 more. So that's 2 lone pairs. And we are done. Now we can actually see the bonds. And for each one of them, it's a chlorine to iodine single bond, right? Chlorine to iodine, chlorine to iodine. That's what we're looking for. Is this chlorine to iodine a polar bond? Now, if they're just asking for bonds, you don't have to bring all of them out. Just look at one if they're all the same. So let's see, let's put Cl bound to iodine. Nobody cares about the electrons, the lone electrons. Nobody cares about that, because if you want to find out if that's a polar bond, meaning that it is not a symmetrical sharing. Somebody's a little greedy when they're sharing these 2 electrons in the bond. And the greedy one is always going to be the more electronegative element. But the polar bond always has a electronegativity difference of 0.4 to 1.8. Now know that, just a difference is subtraction, right? So all we have to do is just find out the electronegativity values for chlorine and iodine, subtract them, and see if it fits in the realm of the polar bond. So let's see, chlorine, as far as electronegativity, has 3.0, and then iodine has 2.5. Now when you are taking that electronegativity difference, just know that that should always be a positive number. So whether you take the big number minus a small number or the small number minus the big number, if you get a negative, just make it positive. It should always be the absolute value. So when you do subtract these two, you get 0.5. And now you say, okay, does 0.5 fall into this range? Yes, it does, barely. But nonetheless, it is classified as a polar bond. So that means that the 2 electrons are a little bit more closer to chlorine because chlorine is more electronegative. All right, now let's talk about that dipole moment. Now, instead of looking at the specific bonds, now we're looking at the molecule as a whole. A dipole moment means that as a whole, there is a electronegativity asymmetrical electronegativity difference somewhere, meaning that, you're not going to have a fully symmetrical molecule. Dipole moments only exist in polar molecules. So the first thing is we just have to find out, is this polar? If the whole molecule is polar, it's got a dipole moment. So this is where SNAP comes into play, S-N-A-P. If you are fully symmetrical, you're nonpolar. You have no dipole moment. But if you are asymmetrical, you are polar. Now, there's one huge piece of information that I can give you that will help you out greatly. Now, don't worry about who the atoms are for the first spot, because what I always like to do is I always look at the central atom first. If that central atom, who's ever in the middle, if that central atom has lone electrons, so the dots, you're looking for the dots. If your central atom has dots, it is automatically polar, no exceptions. So I go straight to iodine. That's the one that's in the middle. And when you look at that, it's got 4 electrons, got 4 dots, 2 pairs. 2 pairs are better than 1. This is going to be a polar molecule. So that's a cool trick to have in your back pocket. If your central atom has dots, it's automatically polar. And because of that, it's got a dipole moment. And that is the final answer. So this one has polar bonds, and the molecule as a whole is polar, so it's got a dipole moment. And that's it. Thanks for tuning in. I hope this helped. Let me know in the comments. Subscribe to the channel, and I look forward to helping you in more questions. So, yeah, come back. Love talking to you guys, and I'll talk to you soon. Tell your friends, tell your classmates about this cool channel. I think it's pretty cool. Free education for all. What a beautiful thing. Anyway, I'll talk to you soon. Bye-bye.